Okay, so this is Janet shoveling snow. This is 2010, number 1. Of course, they give you number 1 as the hard hello to the AP test, but that's okay. Okay, so I'm going to assume that you've read the problem. The first question says, how many cubic feet of snow have accumulated on the driveway by 6 a.m.? Accumulation means the integral of the rate. So if I want to find accumulation, I have to integrate the rate at which something happens. So I need to go back to the problem, and it says, oh, snow accumulates at a rate of this. Right? So that is the rate at cubic feet per hour, where T is measured in hours since midnight. So they want to know how many cubic feet of snow have accumulated by 6 a.m. Now, if I look, it says that she doesn't shovel anything until 6 a.m. So that means I don't have to worry about her shoveling and snow falling. So all I have to do is integrate from 0 to 6, right? This is a calculator problem, so I'm not gonna, you don't know how to do this by hand, so we're not gonna worry about it. And so this is just if I plug it into my calculator. That's what I get. Okay. For part B says find the rate of change of the volume of snow on the driveway at 8 a.m. So the rate of change of volume of snow. So what's happening here is that the snow is falling, but Janet now is shoveling, right? So it's falling and she's shoveling. What we can do is, it may seem like we can't do this, but all we have to do is subtract the two rates, and that'll give us like a net rate. So a net rate is the snow falling rate minus Janet shoveling rate. And we evaluate at T equals 8 because it's at 8 a.m. So all I have to do is do 7 times 8 e to the cosine of 8 minus, now if I look at Janet's piecewise function, it says her rate is 108 between 7 and 9. So all I have to do is, so this is f of 8 minus g of 8. And that number is negative 59.582 feet cubed per hour. Okay, so she's shoveling a volume. The reason why it's feet cubed is because that's the volume of the snow she's getting, that's being shoveled off the sidewalk, and so, or her driveway. Because it's negative, Janet must really be putting in some serious elbow grease there. That means that she is shoveling it faster than it's falling, which is good. I mean, most people probably shovel it faster than it's falling, I would hope. Of course, you guys don't really have, some of you don't have driveways, so maybe you've never shoveled a driveway, but hopefully you shovel it faster than it's falling. So this number should make sense to us. Part C is the killer here. Let h of t represent the total amount of snow in cubic feet that Janet has removed from the driveway at time t hours after midnight. Express h, which is going to be our total amount of snow, as a piecewise function with the domain of 0 is less than or equal to t is less than or equal to 9. So what I'm going to do is I have to integrate her rate, because total amount, again, is equal to the integral of the rate. Okay, it's another word for accumulation. So what I have to do is I'm going to consider what's happening. So at 0, right, at 0 we see she's not shoveling any snow. Okay. I'm going to have to consider the endpoints here, like meaning we can see at 0 she hasn't shoveled any snow. And so, for example, this is what I know, if you look at the grading guidelines, they have this first. That means she's not, the rate at 0 is 0. She's not shoveling at 0. Okay, so we don't have to add, she hasn't already shoveled anything. That's why they have that 0 in there, and I'll show you. So for 0 is less than t is less than or equal to 6, because we say that we use this less than instead of less than or equal to, because we're not including, and this is true for each of these increments, we're not necessarily including what happened at 0 in this part of the piecewise function, because we don't theoretically know in the piecewise function what had been shoveled before then. We know nothing had, but that's why they do it that way. Because what if she had already been shoveling for an hour and you were just writing a piecewise function for the middle 2 hours of shoveling? Then you'd have to consider how much she had already shoveled at the time you start and add it to whatever you find she's shoveled in the following 2 hours. Hopefully that makes sense. And I'll say that again later. So for 0 is less than t is less than or equal to 6, h of t is equal to h of 0, because h of 0, again, that's how much has been shoveled already. We know nothing has been shoveled yet, but that's how much has been shoveled already, and that's why you have to add it to the integral I'm about to write down, because if it had been more than that, she had already shoveled 10 feet, you would add that to the amount of feet she would be shoveling from 0 to 6. Okay? So, we know that 0 plus from 0 to t. Again, when you're doing these total, these kind of accumulation problems, sometimes they like to use variables in the integrand. So, it's okay. I'm pretty sure it's okay if you don't. I'm almost 100% sure it's okay if you said from 0 to 6. The problem is that you're not always going to necessarily include that endpoint. But, so of g of s, ds, so in other words, 0 plus, now from 0 to 6, she's not shoveling anything. So it's 0. That is what the rate is. Oops, not dx, ds. So that's just 0, because it's 0 plus 0. Okay? Now, for 6 is less than t is less than or equal to 7. Again, the reason why I don't include 6 is because we're now talking about all of the snow that's being shoveled between 6 and 7, including at 7. Okay? Because if you include 6 here, then you'll have done it twice. You'll have added the amount of snow that she's shoveled at exactly 6 a.m. twice. So we can't include it both times. Okay? So hopefully that makes sense. So that is h of t equals, now I'm adding the previous amount of snow that's been shoveled, because I'm adding it now to what I'm about to find has been shoveled between 6 and 7, plus the integral from, now again, I believe you can just do this, 6 to t, right? The biggest reason you're going to actually use t here is because they want a function. They want a piecewise function. So if you just use numbers, then all you're going to have is numbers when you get to finishing writing out your whole equation. So you need to have this t, because I need to end up with something with t, because I'm writing a function. Okay? So I'm going from 6 to t of 125 ds. So that is the next branch of the rate that she does this, okay? So h of 6 we know is 0. And so when I evaluate the integral, it's 125t minus 125 times 6. So you can absolutely leave it like this. You don't have to you don't have to factor out the 125 if you don't want to. Sorry, I wanted to make sure I did 125 times 6 correctly. You don't have to factor out the 125. You can leave it like this. That's fine. Okay. Now, I've already included 7 up here. 7 has already been included here, so I'm not going to include it down there. Okay? I'm now curious as to what she has shoveled after 7 a.m. because I've already counted what she did at 7 a.m. So now I want to know what happens at 7:01 until 9 o'clock. Okay? So that would be whatever was happening at 7. Whatever was happening at 7. Plus from 7 to t of 108 ds. Okay. H of 7, the way I get h of 7, in case you're wondering, because I have to add h of 7, I have to add this. This only tells me what I've shoveled between 7 and 9. So I have to add the previous amount in order to tell me, for example, at 9 o'clock. If I want to know how much she shoveled at 9, I have to add the previous amount to the amount between 7 and 9. So if I'm curious about how do I get h of 7, I go back to this guy. Remember, this is h of t from 0 to 7, or 6, sorry, from 6 to 7, including 7. So this becomes now, h of 7 is 125 times 7 minus 750 plus 108 times t minus 108 times 7. Okay. And in case you're wondering, remember, this becomes 125t from 6 to 7. Right? This becomes h of, I should write, 108t. And really, I should write over here h of 6 plus okay. So now, 125 times 7 minus 750 is 125. So this gives me 125 plus 108t minus 756. Okay, so now I'm ready. This is, right, now I'm ready to put this all okay, so h of t is 0. We found from 0 is less than t is less than 6, so equal to 6. Then I found 125t minus 750 from 6 is less than t is less than or equal to 7. And 125 plus 108t minus 756. I can totally combine like terms. I just didn't. And there you go. That is the the culmination of part C. Okay, let's go on to part D. So now they want to know how many cubic feet of snow are on the driveway at 9 a.m. Now, what you have to consider is that, again, this is accumulation. So this is going to be the integral of the rate. The only thing here is that snow is falling and Janet is shoveling it. So I need to take into account the fact that it's falling and she's shoveling. So what I want to do is I'm going to go from 0 to 9. So the rate that it's falling I need to find that. Okay, that tells me how much snow has fallen. And this is okay. So you can put that into your calculator, 0 to 9 of, I'm not gonna, right, you can integrate that on your calculator. And what you're gonna do is you're gonna subtract the snow that she has shoveled. Now, we know how much snow she's shoveled. We just found it out in the previous part at 9 o'clock. So what I can do is I can just find h of 9, right? Because this is the total amount of snow by 9 a.m. Okay? So when I do that, I'm going to just let you do this part on your calculator. Minus h of 9 is 125 plus 100. Did you minus 125 plus 108 times 2. And when I do that, I get feet cubed. Okay. Now, is this problem the hardest problem on this exam? I would think so. This is going to be the toughest problem that you would see on the AP exam. That means you should probably do it last. Don't feel like you have to spend all this time doing it first. It sucks that it's question number 1, but if you know you're having trouble with these accumulation problems, like if you see the word accumulated, come back to it. This is a calculator problem, so you will only have one other problem to do after it, but do that one first and then come back to this problem. You should be able to at least do part A and B. B might be a little confusing, but A you should be able to get. Because you should, as long as you know that the integral of a rate gives you accumulation, or it gives you what we call net change, the change in the rate. Or the change in amount. I'm sorry, not change in rate, change in the amount. So that is how you do the Janet problem, and hopefully this helped. All right.